So particle P moves in a straight line on a horizontal surface, passes through a fixed point O with velocity 2, so it's going 2 meters per second there. And we've got acceleration equals 4 plus 12t. So this is going to be general motion in a straight line. Calculate the velocity of p when t equals 3. Well, I know that acceleration equals dv by dt, and I'm told that that equals 4 plus 12t. So what I have to do is integrate this, and that will give me that v equals the integral of 4 plus 12t with respect to t, and so v equals 4t plus t is going to have to power increase, t will have to increase, so that'll be 2, that'll be 6t squared plus c. Don't forget the plus c. So when t equals 0, we know that v equals 2, and therefore we get 2 equals 0 plus 0 plus c, so c equals 2. And so now we know that v equals 4t plus 6t squared plus 2. And I can now find it out when t equals, so v will now equal, when t is 3, that'll be 12 plus 9, 54 plus 2, which equals 68 meters per second. Part 2 I'll do up here. Find the distance when t equals 3. So now I'm going to have to do the same thing again. I know that v equals this, but v is dx by dt. So dx by dt equals 4t plus 6t squared plus 2. I'm going to have to integrate this, so x will equal the integral of that expression. Don't forget, while integrating, I'm going to have to get the plus c, and so that will give me x equals power increases t squared, that's going to be 2t squared, plus power increases integrating, so that'll be 2t cubed plus 2t plus c. And when t equals 0, then we get x equals 0, and that implies that's 0, that's all 0, that implies that c equals 0. So we get our things. So when t equals 3, x will equal 2 times 9 plus 2 times 27 plus 2 times 3, so x will equal 78 meters. Part 3. Okay, so second particle q, having the same mass as p, moves along the same straight line. Displacement of q from O is this. So when t is 0, it's k, so it's starting right over here. That's where q starts. And we know that when t equals 3, the particles collide, so they must be exactly the same distance, and they coalesce. So all I need to do to find the value of k, I need to know displacement here, and that bit's, so k minus 2t cubed, that must equal 78 when t equals 3, because there must be the same distance there because they collide. And that will give me that k equals 78 plus 54, and so k will equal 132. And part 4, a lot of marks for this. Find the common velocity of the particles immediately after their collision. Well, so we've got a collision, so it's got momentum, so I'm going to do it like that. And the mass is the same, so I'm just going to put m in the middle of each of those. This one is going, what's that speed? 68, I worked it out earlier. This one, I don't know this speed. And this one, they coalesce, which means they sort of stick together. And so both of the velocities there must be v. I need to work out what the velocity is. Obviously moving this way. I'm told what our thing is. So x equals 132 minus 2t cubed. And I want the velocity, so dx by dt. Differentiate that. That will give us minus 6t squared. Differentiating it, and when t equals 3, v equals minus 6 times 9, which equals minus 54. So this bit must be 54, and it's going to the left. And now we can do it. Total initial momentum, which is m. I'll write the formula out. Total initial momentum equals total final momentum, and momentum is mass times velocity. So it starts off with mass m times 68, so 68 m. And this bit is the velocity is minus 54, so it's to the left, and so that'll be minus 54 m equals my final velocity, which will be 2 times mv, because I've got mv here and another mv here. The m's cancel out, and that says that 2v equals 14, and therefore v equals 7 meters per second. And that's question 6 done.